Yes.
Thanks, Ray. Yeah, Joy, should I start or let me start. I will start by sharing my screen. So we prepared a small presentation for you guys today to talk a bit about the topic of today, which is, if this thing opens, Masters of State. Yeah, we like to call ourselves Masters of State. So we thought let's share some of its expertise, and then especially on observables and then the Akita pattern using Firestore. As you can see already from this image, there's a small dog over there, which is an Akita dog. We're not talking about the dog today, we're talking about the pattern. And what the Akita pattern allows you to do is basically conduct what we define as acceptable or proper state management within an Angular application. Now, maybe before we start, a bit about ourselves. Yeah, we're calling here from our office here in the center of the Westlands, Nairobi. My name is Jente. Yeah, I'm a computer scientist by trade, so I work for a lot of organizations as a cloud architect, to be specific. Lots of Angular projects, but also in different technologies. The technology depends on what the clients need, but I'm also an educator by heart. So back in 2015, I started a company called Alewa, where you can see the logo here, where we do everything to do with large-scale professional training. Using my cloud architecture background, a spin-off that came out of that is the Atalanta that you see over here, where we find very talented people such as Joy, who is here with us today on this call. And we bring them from already a bit experienced in technology to very senior in a couple of months or a very few years. Now, I'm actually from Belgium originally, so that's why half of the flag represents the Belgian flag, but I'm also these days half a Kenyan. I've been here since the last 5-6 years. Yeah, and I'm not leaving anytime soon. A bit about myself from a code perspective. So as I mentioned, the cloud architect, I'm also a Google for Startups accelerator mentor, helping startups across the continent, but also in other places. Think about architecture, think about how are we developing applications that won't be useful for a few months and then break, but that can last for 10, 20 years and beyond. So yeah, that's a bit, I've already talked too much about me. We also have Joy over here. Maybe Joy, you can say some words about yourself.
Hi, my name is Joy. I'm a software developer at Atalanta. So it's been, I think I celebrated my 1-year anniversary 3 weeks ago at Atalanta. And yes, I have to say that, yeah, this is a pretty good place where you can grow professionally as a software developer. I've been taught a lot, like being language agnostic, always aiming to be a full stack developer. So yeah, that's a little about me. Yeah.
Joy, you didn't talk about data. It says a lover of all things web, but she's also a lover of all things data, which she might be able to talk about later. Maybe a bit about our program, just what we do here at Atalanta. As I mentioned, what we find is talented people such as Joy, and we put them through what we call a 2-year accelerator program. We call it an apprenticeship, but it's already real hard work for clients across the world. So we have startups in Europe, some here in Kenya as well. And we take over all of their software development. So we do a lot of Angular, we do some Flutter, we do some Golang, we do some Rust. It really depends on what type of startup that we service. So we work mostly with startups. And again, what we do for our startups is we build teams and we build applications that are built to last and that achieve all of their objectives. So we bring, on this project, we bring our junior developers up to lead or senior developers over the course of 2 years. Some people do it faster. The fastest we had so far was one a bit less than a year. It's on-the-job training, so it's not a school and then you go and do the job. No, you do actual work for actual clients, and at the same time you're supposed to grow very fast, because if you don't grow fast enough, you also won't be able to do the job. Yeah, we have different types of projects. They range from fintech and accounting to agri-tech to HR tech to edutech, so it's a bit of everything. And yeah, it's on the job, but it's also personalized learning. So we try to find what are the strengths, what are the weaknesses of our apprentices, and how can we make sure that after the program only strengths are left. Now that's enough about us. What we want to talk about today is a topic that often gets neglected, I would say like that, but is one of the key features that and the key building blocks on which proper applications are built, and that is state. Just quickly about what is state. I don't know if anyone wants to give a definition. Maybe we can start like that. Wayne, or maybe Joy, Joy, as I talk, maybe you can moderate and see if someone wants to raise their hand and tell us what state is. I've already given some hints. No hands yet. I'm gonna give it 10 more seconds. Come on. I will be giving Belgian chocolate who gets it right. You can come and collect anytime. No, people are still too shy. In that sense, state is actually.
No, Wayne raised. Wayne raised.
Ah, okay. Someone wants the chocolate. Perfect. Wayne, what is state?
I don't know how I'm gonna get that chocolate because I'm in Mombasa.
I'm traveling there soon. I'll bring it with me.
Yeah. Okay. But I think in simple terms is state management is more of a way of ensuring that if I use loosely translated, it's more of like trying to make sure that you don't hit your API endpoints every now and then, but actually like do things like caching onto the user side so that they don't have to be hitting your API endpoint every now and then if they're still on the same browser. Yeah.
Okay, anyone wants to, that is okay. That is a part of state, but that is not state. I wouldn't even call that state management. I would call that state management in a particular case, because you're now assuming that you're using API endpoints. So I get one more try. So not yet the chocolate Wayne, but you get other chances as we go along. 5, 4, 3, 2, 1. No one, Joy? Okay. Huh? Ah, Alamin. Okay, Alamin, you can try the chocolate.
Okay. According to me, I think state is like a pattern where you want to ensure that across your whole application, you are maintaining the statefulness of your application. That means from your database queries to your front-end components to how you talk to your RESTful API, if it's GraphQL or REST, or if it's REST, like maintaining that statefulness of the application.
Okay, that is also not going to earn you chocolate, but it is giving us a very good opening to talk about state. What you talked about is more state management, and it's the same as what Wayne talked about, but it is not state. State is simpler. State is just data. It is data, but data at a certain point in time. Now, as you mentioned, Wayne, you want to hit an API point, and if you hit an API point, you're going to get something back. In this sense, you're going to get data back. And that data you're going to visualize in some way. The data could be different forms, which I'll talk about later. But the data will form part of what is your state. So state is a very difficult concept to explain because it is, but in its simplest form, it is data at a certain point in time. And all the data that we might need to run our application. There are different types of state, and state also can have different subjects. You have application state, and application state again is split down into front end and back end. Your back end might be ahead of your front end when it comes to its state. For example, if let's say 2 people pull in a website, and I pull in a website at 8 o'clock, someone pulls in a website at 8:30, okay? The person that has pulled the website at maybe 8:30 will now click a button and fill in a form, and data will go from his website to the backend. The backend therefore will now have this extra user, this extra form filled, and the state of the backend will have more information than this other person that has maybe loaded his website at 8, 8:15, 8:29 before this action happened. I don't know if I'm confusing people, just interrupt me. I'm trying to go step by step. But what I'm trying to say is that if this person has not refreshed their browser, and maybe the state I'm getting on the front end is a list of all the users, I have added a user, but I have not refreshed my browser. That means my application state on the front end will know less than my application on the backend, because my backend has already gotten more users since I've loaded my front end page. Okay, so even with caching, you can get into these issues where your front end is out of sync with your backend. Your backend knows more than your front end because you have cached certain data, and the data is not refreshed. So as your backend continues to add data, your front end is still a bit behind. So application state has a subject that means that the state of my front end can be different from the state of my backend, can be different from even a part of a backend function. Because if you get into things like race conditions where two functions are racing to be the first, they might have different states at almost the same time even. The application state is a bit of a vague concept because it is living everywhere. It is living in your functions. It is living on a database level. It is living on an application level. Other types of application state is, for example, UI state. It's close to, you can call it almost the same as front-end state. If I click a button on my UI will know that, and I'm not allowed to click that button twice. My UI might know that button is already clicked. So don't let this person click twice. My backend is not concerned with having such data. My backend is only concerned with, is this form submitted and how do I take note of this data? So at different stages throughout your application lifecycle, 3 different states exist. Another one we wanted to talk about just to illustrate this concept of what is state is protocol state. And HTTP is a very good example of protocol state. And you also used it as one of your examples. For example, Wayne and Alamin also talked about it. It is if I hit an API endpoint doing a request, whether it be a get, a post, a put, or options, I will get a response at a certain point in time. That response I can cache on my front end if I want to. That response I can even cache on my server if I want to. So for example, if I have, let's say I'm building a system using Python, Flask, or Django. These things are built using an MVC pattern. So they build your front end on the server, and then they send you plain HTML to the front end as a rendered web page. Of course, there's Ajax, which you can argue, but most basically, that's the process. I request a website, get me this website, and I get HTML, CSS, and JavaScript back. Okay, that is a normal way for 2 stateful applications, whether it be my web browser or my server, to interact with each other over a communication protocol. That communication protocol itself has state. And in HTTP is actually an exception because HTTP is what we call stateless. What does stateless mean? This is the process of, this is actually a graph that shows you how to implement, this is a process that shows you how to implement, what was I saying? An HTTP server, okay? An HTTP client. It starts with beginning. Do I need a connection? No. Do I need a connection? Then of course I'm going to break my connection. Do I need a connection? Yes. So this is just a process of how do I implement an HTTP protocol basically. Now, every time I am going to establish a connection between my browser and my server, I have to go through this whole process again. So that means I have to reach out to the server in what we call the handshake between the client and the server. I have to put in place the security, meaning the caching and the encryption and all of those things. I then need to make sure that we are talking in the same language. That's part of the encryption. And then I'm going to send a bit of data. In this case, I'm going to send the data request that way. I'm going to add a response back. And then I'm going to kill that connection and start again. That means if you look at the different type of requests you have, if you, for example, do an options request, which is in this case of cross-origin websites, which I won't go too deep in now, it means that for each post request, I'm doing 2 requests, okay? I'm doing an options request, then a post. Whenever I do the options request, which is what's called the pre-flight, I will have to establish a connection, send an options request saying this is where I am, get a response back, okay. Immediately after that, I'm going to do a post request, which means I need to establish the connection again, tell the server this is where I am, this is my data, give me a response. Every time you're doing HTTP, you're actually going through what is called a stateless process because you have to start from scratch. There is no data stored on the protocol. Every time you do an interaction, you are starting from scratch. So if that is stateless, then what is stateful, okay? And stateful, just to take it on the basics, an example of a stateful protocol, and I'm talking about protocols now, I'm not talking about applications or anything, just to give an example, is a socket, okay? Whether that socket is over TCP, UDP, ICMP, MQTT, there are different types of sockets that you can establish, and a socket basically means a connection between a server and an application, okay? Client-server relationship, they usually go over sockets, and there are different types of sockets. There's sockets everywhere. You can go for the raw stuff, which is the TCP or the UDP. The difference between TCP and UDP is usually that in TCP, I'm trying to establish a connection where I'm sure that my connection arrives, that my message arrives, while in UDP, I try to optimize for speed. So usually a socket connection such as Netflix is a continuous connection. If you're going to your Netflix, every frame you're going to send, you're going to use UDP because you don't care if one frame arrives or not, because there will be enough out of the thousands and millions of frames you send, there will be enough which arrive for you to stream video at a proper streaming rate. So it will not show like it will not feel like your it will not feel slow. You want to go to make for speed. If every time Netflix sends you a frame, you need to acknowledge that you received the frame, the whole video will be way too slow to load. So also in gaming, for example, you just want to optimize for speed. You don't care whether the message arrives or not, but you have a continuous connection between the two. For example, over my UDP, I could be the one shooting. That goes up to the gaming server. Whether the thing has hit or not comes back in real time. So it's a constant back and forth. I don't need to establish a connection every time I'm going to go to the server and back. So the state of the protocol, knowing where is my client, where is my server, it is stored inside of the session. TCP is again, if I need to know if something arrives, but it's slower, of course. So an example of where we use TCP connections directly. Recently, we had a project where we had to work with something called an EPP server. So basically, if you are going to register domains and you're going to be a domain registrar, so we were building a domain registrar basically, you're going to immediately establish a connection with an EPP server, which is the Kenya government, for example, has a server where you can buy domains. And that will be a two-way connection that in real time you control. This is the raw stuff, but as you go up, we have built some tools that make it easier to work with these type of connections. The first one is MQTT. People who have worked with RabbitMQ might know that protocol. It is what we call the pub/sub, publish, subscribe. I subscribe to a topic, I listen to a topic. But it's not like in HTTP where I need to go do a polling technique. Every time the topic updates, I need to go and reach out. Whenever something updates, it will come to me. So again, for that to happen, there needs to be a continuous connection. To have a continuous connection, that means you have to have the stateful protocol. Observables, values which change over time, which we'll also talk about today, are also an example of us making life easier by building protocols on top of protocols. Firebase collections, another example is just a wrapper around a TCP connection, around the UDP connection that has a specific use case. It means that if we work with Firebase collections directly, what am I trying to say? We do not need to know the complexity of dealing with the raw stuff. Instead, we have given a framework for data that changes over time again, or for working with a database such as Firebase Firestore. Very funny, HTTPS and HTTP are actually also done over a socket. It's only that we've built a protocol on top that make this client-server connection easy to do and understandable, and allow us to use API integration patterns and those type of things. So if you look at that from an OSI model, I don't know if anyone knows the OSI model, it is the layers of transport, the layers of networking. You'll find that as we go up in these different types of technologies that we actually use as programmers, you're actually just building it on top of a lower end stuff, which is the TCP and the raw UDP connections, which live in the session layer, not the application layer. But that doesn't mean that it's impossible to work with. As I mentioned, we have done projects where we work with TCP connections directly and sort of build this presentation and application layer on top ourselves. What's very important is just to realize all of the connections we are having between a server and a client, they are actually stateful. It's just that we have twisted the HTTP protocol to such a state where for us to easily develop with it, we have made it stateless. Now, if we are starting to look at, okay, this is a lot, and I don't even know if this explains the concept between stateful and stateless properly, but it is just to introduce this concept of sockets where you no longer have a one-time me reach out to him or her, him or her respond to me, but it becomes a two-way street, a two-way connection. And what I try to also say is that me reaching out to you and talking to you and getting a connection and getting a response, even though we have turned it into a protocol, which is a single round trip. I talk to you, you give response. I have to initiate again for you to give response. That medium itself already goes over a two-way connection. Now, this is where a bit where I stop the complex example of what is state, and where I give the microphone to Joy for the fun part, which is now what can we do with these type of connections, with this type of two-way connections. And that is when we come to the observable.
So I'll be talking to you about observables. So an observable is basically the metaphor I like using when talking about observables is picture them as an array of feature values which are spread over time. So RxJS is a library that was built for supporting reactive programming, which makes it easier to compose asynchronous programming. So observables support different kind of operations. Next slide. For example, the mapping. The map operator in RxJS transforms values emitted from the source observable based on a provided callback function. So this basically transforms data. The filter just it filters items based on a particular condition which you've passed it. Yes. Yeah. So Yente. So there are also other operators that can be used to manipulate time. For example, the debounce method, which basically is a filtering operator that emits a value from the source observable only after a period of time. And then we have the combine latest, which just waits for any observable to emit and provides an array of the last emitted values from all the observables. This can be basically be used when loading a page, for example, and we want to load from different data sources. So combined latest comes in handy because you're listening to different stores or services. Yes. The last one is the switch map, which basically if the previous observable is not completed, it cancels it and then subscribes to a new one. Yeah. So observables in Angular are very important because as Yente has said, when working with HTTP requests in Angular, HTTP requests are wrapped as observables, which is easier to implement and make parallel and subsequent requests using observables. You can also use observables when working with reactive forms. Also when implementing guards in your system that return an observable of a Boolean type. that check whether a user can visit a particular page or not. There are also root solvers that basically use observables until it does not root solvers. What they do, they just wait for the data to come for them to render the page. So yes, I think that's all for me on the observable side. Yeah. And there's the link for you to get more operators and learn about many or more of them. Observables are fun to play with. There's this description which Yente gives us. It says picture observables as a pipe of water or something. So you're subscribing to every drop that comes on the other end. You're listening to every drop that comes on the other end. So again, I'll give way to the microphone.
I think Gente is on mute.
I didn't know how I get muted, but quickly, let me share my screen. Good. Everyone can see, yeah?
Yes, yes.
Oh, okay, perfect. So the most important thing to realize, to remember about observables is that they are values which change over time. And this is a whole new concept because some of you might be able to, might have worked in the past with something called a promise, okay? A promise is more in line with what we have here, which is the HTTP request response, okay? With a promise, I am going to promise that something at a certain time in future, I will have an answer. So for example, if I do a request to a server, that initiation of the request returns usually a promise. And that promise that my API, that my SDK returns is that at a certain point in time, I'm gonna get a response. And if not, I'm gonna crash, which is also a valid promise. It's just telling you I'm either gonna resolve and give you data, or I'm gonna crash. I don't know, if you've worked with promises, maybe raise your hand. Then I know we can also work from there. Joy, is anyone raising their hand? So no one has worked with promises. I can't believe that. Good, good. I even see some people here are raising their hand in person. Perfect. With an observable, we no longer need to, it becomes different. The value can change over time. And this is very difficult to explain. So the best way for us to explain it is by just showing you. And that showing is what we will do later in the demo. And now when we start with something called Firestore. Now, what is Firestore? Firestore, first of all, is part of what we call Firebase. And Firebase is this new concept that came up, in the last 2-3 years, which is backend as a service. So basically, Firebase is this suite, and we'll also show maybe a demo and what it looks like in a bit. Basically allow you to build a backend without needing to install servers or so it has serverless features, or without needing to take extra steps to track everything that's happening on your application. Is an element of Firebase. So Firebase is this big backend as a service. Firestore is a small element. And Firestore, what is it? It's a NoSQL document-based data. One of the things that I hammer into people that are just starting with. Okay, where did I get stuck? Okay, so Firestore is the part of Firebase, which is this huge backend as a service. And what Firestore is, it is a NoSQL document-based database. So for those that have worked with something called MongoDB, MongoDB is also a NoSQL document-based based database. What I wanted to say, and where I got apparently stuck, is that NoSQL doesn't mean denormalized. I mean, this is usually the first thing that I tell people that are starting to work with a NoSQL database. All of the ways in which you would design a database, just the way in which you, with your tables and with your foreign keys, it is still possible and it is still a must to do all of that, even if you don't have SQL. What a NoSQL means is that the database doesn't depend on the ACID principles. It doesn't mean that you don't have to use good database design. You have to use good database design. That is a side note and a rant on my side. Another thing that you need to know about Firestore is that it is unique in that it has both document storage properties as well as graph-based properties. And we'll show that in just a second once we start our demo. So Firestore is a mix, and this is a very unique thing. I've never seen it in other databases. Now it's starting to come up though. That you can have both the advantages of a document-based database and then combine it with how you would use a graph-based database. And I'll use some practical examples as we show the demo on what advantages this can give you if you architecture one applications. Firestore is highly performant, highly scalable, unlimitedly scalable. It is cheap if you know how to use it. Very important if you know how to use it. And it has this other property that means that its values can be observed. So values can be observed, might ring a bell when it comes to observables. And we come back to that later. Before we do that, let's just do a quick demo. And for that, I need Joy to share her screen.
Can you see my screen?
Yes.
Here we are.
Just a second as we set up the logistics. I don't know if everyone can hear me properly.
Yep, loud and clear.
Good. What we are going to build today is just a flower shop. We're going to use an example of just a simple web shop. Yep. If our Firebase agrees. Where we are going to have categories of flowers, and then based on that, you can dive deep and actually go and buy some of these flowers. That's actually a very simple state example. The website looks something like this. We have our flower shop. I have lilies, roses, and tulips. If I click roses, I can see a bit of detail and the different roses that we are selling. In this case, that red roses. There seems to be a problem with our navigation of the simple example that we just created right before this workshop, but that are details. The first thing that we want to see, I don't know if anyone has ever seen Firebase, and that's why I wanted to take just some time to go through the platform. The first thing you see when you load a project in Firebase is an overview of the different items that you've activated into Firebase. As you can see here, we have 4 categories in Firebase. The first one is build, and under build, I have the most important stuff, authentication. Firebase comes with a full authentication suite. So all of the things you usually struggle with how do I let users log in? How do I, what if they forget their password? What if I want to let them log in using Google, Facebook, all those things? With authentication in Firebase, they take care of all of that. And the only thing you have to do is spend 5 minutes integrating your SDK, and you have cutting edge OAuth 2.0 in your application. Firestore we'll talk about today. Another database they'll have here, as you can see, is real-time database. Cloud storage, which basically means storing blob files, images, those type of things. Firestore hosting, which means a CDN, a worldwide platform where basically if I host a website, it goes across. So you no longer need to upload it to a server. You just upload it to Firebase, and you don't even pay for people visiting your website. Hint. Functions, serverless. We have another talk on that, which I can share in the description if that is interesting to people, how to work serverless. Machine learning, those are the real core features. That is how do I build an application. But then it also has release management. Once my application is released, how do I make sure it's not crashing? How do I test different features, for example? How do I distribute my app? This is also mostly for Android and things like if you would build it in Flutter or you will build it in Android, this is what you will focus on a lot once your application is live. For web, we try to focus more on the analytics. This is also more for this is also works on Android, but you can do some cool things such as track, create user funnels here, identify key audiences, things like that. And then engage is what we call growth hacking, which is a whole other topic, but very interesting if you go into commercial application development. Now, all of that thing aside, I just wanted to quickly introduce Firebase for those who haven't used it yet. What we want to look today at is Firestore. And Firestore, again, has different things. It can has security built in. So you can define rules and basically make sure that only people who are allowed to access certain data you can access the data. This also merges perfectly with authentication, so you can use a role-based system and build it on even field level security. And then usage, of course, how much have I pulled the data, how many reads have I done, how many writes have I done. And this is very important because once you reach these 50,000 reads and these 20,000 writes, you start paying. So of course, we want to stay below those. If you use Firestore effectively, we've seen some cases where it really reduces cost of running an application. So what that means is basically, if I have production systems, so we have production system in place that have over 500 users, fintech systems, very heavy. They cost us less than 10, 20 euros in hosting costs, so 1 to 2K in hosting costs per month for 500 daily users on very heavy operations. If you would do that on a traditional stack, you're looking at 200 to 500 or to a couple thousand easily. But as I mentioned, with great power comes great responsibility. If you don't know how to take advantage of the things that Firestore offers you, you end up with extremely big bills. And this is where state management becomes very important. So what we basically do with state management is not only make sure that we can build properly for the long term, it also makes sure that we don't kill ourselves in fees. When it comes to some of these tools that we integrate, such as Firestore or those type of things. So in our state layer, we're actually going to determine how much data do I need to pull in from the database. Now it's time for the fun stuff. We are going to actually use Firestore, and what we've built here is a very simple application. We use something called an X. So we have a policy at the office where we always use what we call a monorepo. And what that means is that our application is mainly loaded here in apps, but that our features live in different libraries. And one of them here that Joy created right before this meeting is the flowers feature. And the flowers feature basically contains these two pages where you have the navigation of the homepage where I can see all the flowers. And then when I navigate to, for example, tulips, I will see some more information about these tulips. So how did she do that? She created two pages which she routes to. One is the flowers home. And the flowers home is a very simple page. It has a toolbar, as you can see here. It has just a simple card in the middle, so something that centers the page in the middle. And then it has different cards, so mod cards, as you can see, for each of the flowers. So let flower of flowers generate this card, put in the image of the flower, put in the name of the flower. So these things are, you can see, of course, oops, where am I going? Here. Yeah, there seems to still be an issue on the navigation that we might need to fix live. But literally, she is just loading an NG4 card image, card label, and that's it. When you click, you go to detail. If you just go quickly to that function, go to detail, you see she's just navigating to flowers / the flower ID. And that navigation will end her up on this flower detail page, which has a bit more because it's now trying to get the quantity, it's trying to get the amount. but this concept is the same. And this is just showing one single flower. This other one was showing a list of flowers. Now, we are not interested in what it's showing. We are interested in how is it getting this data. And what you can, what you can see here in the flowers home component, it implements on init, which means the moment this component loads, it is going to want to do something. And on init, it wants to show me the flowers. What it wants to do is it wants to get flowers.subscribe, which means it basically is going to call. Hello.
Manchester Italia.
We have someone that we need to. Yes, good.
Sorry about that.
What she's basically going to do, she has a service, she gets the flowers, then she subscribes. Now, this get flowers, as you can see, it returns an observable, and it shouldn't be an observable of type unknown, it should actually be an observable of type flower. So a flower which changes over time, or in this case, it is not even an observable of a type flower, it is an observable of a type of list of flowers that change over time, okay? Now, what does this thing change over time mean? Let's look at that, because also here in the flowers detail page, we have this get flower by ID, and then we're gonna get an observable of a flower. So this is an observable of a single flower, a flower that changes over time. Now I'm gonna open two screens, and this is always how I like to show this thing as really something that works. I'm gonna open my database on the left-hand side. I'm gonna open my application on the right-hand side. It's actually opposite. My database is on the right-hand side. My application is on the left-hand side. If I go to Lily's, we have not really built this application to be very mobile friendly. Unfortunately, that's a bit of a pity. But as I can see, my amount is 100, and I'm just going to go to my database, which is my observable source, and I'm going to change it to 150. 1, 2, 3. And before I could even go back, you see this amount has changed to 150. And I did not do any refresh of the page. I did not do anything, okay? So what you can see here is an observable in action. This flower, this lily is listening to my database, and when something changes in my database, automatically my front end is going to change. I think this is too much text. Sorry for all the writing you did, Joy, but this is way too much text. I'm going to update, and immediately my front end changes. So magic. This to us is very normal, but to new people, they usually get shocked with the fact that we haven't even refreshed the page or anything. You don't need to refresh the page. These things happen into components. If I would add another component, and I would call it flower price. So I'm going to add that component. I'm not used to typing with this keyboard. Let me just copy all of these. We're not going to make our life too difficult. This is because I'm in a live presentation. Those people that work with me know I would never accept someone to just copy paste. You know, we should actually switch computers because now they're just seeing me. They should also see the co-host. So price, I'm gonna call this other thing flower price as well. I'm gonna call this third thing flower price as well. Again, if I would be used to typing with this, it would be long done. Now I have 3 flower prices. This now, of course, needs to become a flower shop price. Flowers price dot price. And this is not a page, this is a component. But I put the name page, that one is a detail. It should be component, else I also tend to get a bit annoyed. Flowers price, page.html, flowers.price. Okay, I don't know why there's a dot there, but I'm not gonna change the name. Hub, flowers, price component. And here I'm just gonna get flower by ID. And I'm going to take it one step forward, because now we are still working with, I would say, an observable of a flower. But then we are unpacking the observable. So observables are a specification of something we call the monad, which, if you're interested in that, MONAD. But I'm not going to go into that. Instead, what I'm basically going to do is, I don't want to work with a flower. I want to work with a price. And that price is an observable of a number. It is a number which changes over time, okay? I need to import my observable. But now if I'm gonna say that and usually when we denote an observable, we denote it as $1, okay? This is very important because it shows us the difference between a value which changes over time and a normal value, in this case, a flower ID, which is gotten from the router. I don't see where we get that from the router, so I probably forgot to copy that, I think. Okay, let's see if it works. But if I'm going to say my flower, this dot flower equals my flower service dot get flower by ID, and I'm passing the flower ID, this thing is going to say this observable of a type unknown should be observable of a type flower. I don't know. Let me quickly create that just to be correct. We haven't created a type. And then I'm gonna say it's actually we have our own library, which is called altiote.bricks. All of these things that we're doing today, and using our open source. So everything we use in this specific presentation, all of the libraries. So the altiote is actually our what we use usually on GitHub, but today it seems to also complain, so I'm just going to kick that out as well. That's the issue with live coding. Never things work the way they work every day. So I'm going to say that my flower has a name and that it has a price. Price is of type number. And I'm going to, it's really not easy with this thing. Say that this is an data service. Get flower by ID. So now that I get the flower, I'm going to map this flower. And this is what we call. So usually observables, we pipe them to different filters, maps, or different transformations that we can do. So in this case, it's a map. And I'm gonna map this flower onto the price. So I'm gonna say whenever this flower changes in time, I need something that changes in time, which is not a flower, but a number. So I'm gonna say what I want is I want to map the flower onto the flower dot price. Where's your intelligence? Good. Now I need my RxJS map. And now what are we saying here? This is the unknown thing, because we put type unknown. Good. So now you see I no longer have an error. I can say that my flower, whenever this flower, which is an observable flower, so a flower that changes over time, as you could see when I update the text, the flower changes in time. When I changed, flower initially had a very long text. When the flower changed in time, because I was complaining it was too much text, you see that also the stream, the observable itself, the variable that you have here on the front end, it changes over time. So what I'm now going to say is I don't care about all of this information that you have on flowers. I just care about the price. So I'm going to take a flower that changes over time, and I'm going to turn that living time stream, I'm going to turn that observable into a number, into a price that changes over time. And that's where I get my price observable. I don't know why I called it flower. But now I've actually used what we call an observable map. I am taking a timeline and I'm turning it into another timeline. Now, what I'm just going to do here is very simple. I'm going to say this is in H1. And I'm going to use something that we call an asynchronous pipe. So I'm going to say I want the price, but the price is not a variable. The price is a value that changes over time. So I need to add async. To make sure that my system knows that this is actually a value which changes over time. And what I think I'm going to have to do is this. Unpack it here as price. And then I can actually visualize this price. So what I'm going to have now is basically a component that just shows how the price changes over time. I need none of this. So I'm going to clean it up. I'm going to register my component onto my module, because if I don't register it onto my module, I won't, of course, have the ability to actually load it in. And now what I still need to do, something seems to be crashing. Not cart is not a known element. This comes from the flower detail. Sorry, I was on mute. There's just a small issue with my import, I think. And I just need to look at what is the problem. Flower shop price, if I go all the way up to my issue. Okay, I did not save this thing properly. This should usually not be an issue. Voila. This was a TypeScript issue. So now, ideally on my detail page, once I load it, I should be seeing the flower. So this is now, yeah, of course I didn't put my price yet, so that's the name, flower shop price. Should be below the cart, huh? But it is not resolved. It needs a index, but I just did by ID. It's probably this one. Huh? Did you put an index on this? No. Let's just kill this one for now. Live coding is always fun. Let's see what we have now. Whenever you have issues, console is your friend. Always remember that. And now I have some other problem, but not in my price page. Reading image source, and it is reading image source from since this thing only happens after a certain while, I need to make sure I'm not loading anything until everything is loaded. So I'm gonna put it as loaded here just to avoid this error, which is causing my build to fail and my page to not render. So this needs an ngIf, and this will not do anything until my page is loaded. So that's just a simple guard I put to make sure that this issue does not happen again, I think. If theory comes good, okay, we no longer have that issue. We have no more issues, but then my price is still not showing. And I know why. This is what I forgot to copy. So of course this if never resolves, which is why it was not showing the price. Good, now we have another one. What time is it? Half an hour still, okay. Okay, our price seems to be refusing to show, but that is fine. What we actually wanted to show was that what you're doing right now is you're getting the same data twice. So if I can see that in my flowers price page, flowers price component, I am gonna get my flower by ID, and then I'm gonna get the price, and then I'm gonna display that price. For this to work, the first thing I need to do is know that my flower ID is at a certain point on my URL. My details page needs to know exactly the same. It then needs to know that I can get the flower service, so the data service. It then will pass this thing, which will actually go to categories, get the category with a certain flower ID. So in this case, it will be tulips or roses or anything else. And then do create an observable source out of it. So basically listen to values changing on this specific document. And that's what actually showed you the magic earlier. I'm not listening to a get, which is basically a one-time event where I just want to get the data. So if I do this, for example, and I'm going to, this live coding is not working out, but if I would do the get, and I would refresh something on my Firestore, you would not see it here because I am using a stateless approach. I am using a get and then I close the connection. Well, if I open a value changes, I am actually opening a continuous connection with my Firestore. I am opening an observable connection. So when something happens on my backend, it will translate immediately on my frontend. Now, these are very simple examples, and I'm not gonna risk actually doing the more difficult ones because the code sample that we set up is already crashing a bit. But what we will do is start creating some tutorials in the near future on how you can actually develop some of these Akita patterns yourself. And we're also going to share some resources with you on how it can be done, basically. Now, what I want to do is just go back to the presentation because I see we, here. And actually continue from there, because what we wanted to show was just how Firestore works. And up to this point, we haven't really gone into state yet. So the issues that we were showing in the code base, and this is something I can even do on my computer because it doesn't necessarily need to run. And I haven't prepared the sample here, just a second. Hope. So the issue we were having here in this flower shop is that we still let our components, in a sense, do too much work. So we let our components realize where, find out where to get the flower ID, which in a sense is not a responsibility of the component. The responsibility of a component is to show things. And we're also telling it, yeah, we're also doing some logic inside of it. And this is, for example, an unpacking of observables, all of these things. We want our component, in a sense, to be this dot flower dot get. Something like this. This is something I'm more used to typing. So I want to say this dot flower is this dot flower dot get, and I don't want to care about anything else. That is what an ideal design with a proper state layer looks like. And why? It's because of this concept called separation of concerns. Usually what we tend to do, especially in early projects or when we're just starting out with Angular, is we are putting all of the logic of our component inside of a single component. And this is very clear here, where basically all of this logic, such as getting the flower, unpacking it, getting the router, the flower ID, all of this is too much work we're doing in our component. It is not the responsibility of my component, especially not of a subcomponent such as a card, to know that I am on this page, or to know that the URL looks like this, or to know that, hey, my component needs to be as dumb as possible. And a component that is as dumb as possible is a component that looks like this, where you just have get me the active flower from state, and what you get from, and then jump it into here, and then I'll unpack and visualize this flower. This is what a good component looks like. And a good component does not need more than 21 lines, or maybe a bit more lines if I want to do something like this. By flower. And have another state layer integration, which is my shopping cart store. And stores are observable sources, so we always divide them by this. This dot shopping cart dot buy flower, active flower, or something like that. So that now my shopping cart knows that I want to buy this flower. That's how a component should usually look like. That is not how components look like in the way in which we usually see them coded. Now, I don't think we have much time to go into this because yeah, our code experiment has been a bit of a bit difficult, but we'll get you some proper code examples later on. What we still want to do is talk a bit about Akita, and all of these things that I've been showing on the Visual Studio Code, so on what a computer, what a component needs to be look like, that is actually enabled by the Akita pattern. And the Akita pattern is a store pattern. It is something that, it's a state pattern invented by Nathaniel Bezos. So if you actually go to Chrome and you just look at Akita Angular, you find a whole bunch of documentation on this right here, once my webpage loads. Akita pattern allows for something, a condition which we call semantic state. And semantic state, what that basically means is what I'm showing you here. My components do not need to know anything of what, how to get data, where the data comes from, how to hook that data in, how to make that connection to the backend, how to make that, if the backend changes, the front end changes as well. My components never need to know any of that. They just need to say, get me this data, get me this data. And then it's up to the state to be able to resolve how the data is fetched. So you can actually move everything into the store using an Akita pattern. There's further a unique combo between the Akita pattern and Firestore graph-based properties. What that means is that what I mentioned in the beginning is that Firestore has, it is a mix of a NoSQL database and a graph type database. So what that basically means, once my database loads, of course, this is on, meanwhile, the Akita pattern properly explained. So actually this, as you can see, it has 3,500 stars on GitHub. We also have our own version of it. Which is called ng solid mono. And then you go to, so this is an open source repo maintained by us. If you go to Firestore state, you'll actually find how an implementation by ourselves from the Akita pattern. So this is, for example, the data store. This is a library built to make your life easy when you want to work with Akita. So both work. It is a pity we won't have much more time to go into it in depth, so I'll more keep it for question and answer. But what the Akita pattern basically does is it creates a proper pattern where these queries manage all of your state, so that the only thing your components need to do is call these stores and queries and ask them, what information do I need to get? And as you see how the pattern flows, the components will then do an action which will update your backend, and automatically your stores will change, which means your front end will change because now your database has changed, it translates to the front end. But you don't need to care about all of these things when you're developing components. The only thing you care about is visualizing them. So if I do an update on my component, this whole circle will complete, my backend will update, and my component will update as a result. Again, I don't know how clear that is, but we can leave it for Q&A. And then a levels implementation, there is an open source project, which is found here. Just go into ngFire state, fork the repo, put the repo into your code base, and start using it with, and start working even with some of our guys, reach out to implement some of these things. Now, I think I want to leave at least 15 minutes for Q&A. And I know the last part has been probably extremely unclear. So what I think we can do is just ask questions on maybe all the way up to Firestore and observable managed state management on what state is. I think those are the parts we were able to cover well. And then later we, through maybe the partners here at Angular Kenya, we will be able to share a lot of resources on how to learn some of these other things, and maybe do record another talk or something like that, where Murphy's Law will not interfere with our presentation and our code examples. So yeah, just to round it off, state is all the data of an application at a certain point in time. Observables allow us to track when these things changes and react to it. Actually, why they call things reactive programming is because just as you saw the application changing when I changed the database, you see that the application reacts to changes in state, okay? That's why we call observables reactive programming, because we are just creating things that react to changes in state. It's also called declarative programming. People who have ever worked with languages like such as Prolog or those type of purely declarative languages, observables actually allow you to program declaratively within Angular. And programming declaratively basically means I just need to tell state what I need, and state will provide, okay? We haven't really covered how to develop a proper Akita pattern, unfortunately, but we will share resources on that, and then maybe see if we can do a later talk on that we avoid Murphy law code examples. So I want to thank everyone for your attention so far. I know we've been fast and gone through a lot of content in a very short time, even if it was an hour and a half. But I want to just leave the floor up to you and see who has some questions on all of this.
Yeah, thank you. Thank you very much, Gente and Joy. I know there's been a bit of a hiccup on the demo side, but no problem at all. We can definitely schedule another session, probably for the demo part, and probably if there's anything else we've left out. So I just got some couple of questions. I think I've got like 2 from the attendees. I think one is for you, Joy, and someone was asking, how easy or how hard is it, or how important is it to implement strict typing on observables? Or like considering right now how like from Angular 13, it's becoming a bit more important that you need to strict type your observables or your variables and whatnot. Yeah, so like how important is it instead of just writing of type any?
I think when I attended, I think why strict typing is important is because, first of all, when you just write type any, I think you're overruling TypeScript rules, which is just you have to give, which is strong typing, right? All your variables need to have a type. So you just add in any, yes, your code might work, but it might be hard for you to debug. And I think giving your variables types basically helps you in debugging and yeah, knowing how to manipulate your data at the end of the day. That's what I'll say. That's how important I think strict typing is. Enter, do you have anything to add?
I just wanted to add on that. When we code, we follow the Bible of coding, and I don't know, I don't seem to have a chat where I can drop some things in. Maybe I'm just missing it, but I wanted to drop the link to something called the solid principles. So if you just go to Wikipedia and you type solid principles of coding, or you type it in Google, you will find a Bible of 5 principles that guide proper software architecture, okay? And proper software architecture is as simple as following these 5 principles. Single responsibility principle. As I mentioned during this call, if I want to build a component, the component should have a single responsibility. That means that the component should not have the responsibility to know what ID a certain, where to find a certain ID on a certain route. It is not the responsibility of a component, that is the responsibility of state. So single responsibility says that every component, every class, every object should only have one purpose. There's other principles such as the open-close principle, list of substitution, one of my favorites, but I won't go into that. Dependency inversion, which is very closely related to the dependency injection algorithm also in Angular. But one very important principle of the solid principle is the interface segregation principle. And what that basically says is for each interface, for each front-end element, for each object that you create, you need to develop a certain single specific interface. That means basically in the case of flowers, there should have been a flower interface in a proper design. Everything that we want to develop, especially if we follow things in line with the solid principles, it basically means that we need to specify interfaces for each object in which we use. So naturally, the only answer that is correct on this question is that yes, you have to develop an interface for each type that you use. Because else you're violating solid principles. Usually that alone should be an answer. But what will basically happen if you don't do it is what's close to what, and that is exactly what Joyce says. It will start to get all over the place. So you don't know which types am I working with, especially not in TypeScript. TypeScript is just JavaScript with a nice wrapper around. So that basically means you have everything, all of the good stuff of, at my university, I should just explain it like this. We had a book this big, which is JavaScript everything, okay? It was about this big. We also had a book about JavaScript, the good parts, which was this big, okay? So JavaScript can do a lot, but it can also do a lot wrong. And TypeScript helps us give a framework of the good parts of JavaScript. It helps us stick to the good parts of JavaScript. So what we want to do is not violate principles in TypeScript. As Joyce said, we want to follow them, and following them means that we need to strictly type what we're working with. Do we sometimes cheat? Even us, we sometimes cheat by moving into any and then moving back. But usually when I see someone cheat, it becomes a big problem. So don't cheat. Or you really have to be able to justify it.
Okay. Yeah, thank you very much.
Experienced it firsthand.
All right, thank you. And then this is for you, Gente. Someone was asking, is there any relationship between like Firebase and sockets, or what kind of sockets does Firebase like? Does it use HTTP, or like what's the relationship there?
Okay. So first of all, in my presentation, I went also over sockets. Everything uses sockets. So the web is built into what we call the OSI model, and the OSI model has about 7 or 8, I think it's 7 layers. The lowest layer in the networking is the physical layer. So that means a wire basically, yeah? And then electricity going over a wire, and that becomes a 0 and a 1. That is the lowest level. The second level is switches. So in local networks, third level, it becomes routing. So how do I send from here in Kenya a message to Belgium? It has to go over a router. Even the UDP connection that we have here in Teams goes over many routers. From there, it goes all the way up, and one of them becomes the session layer, and that is where sockets live. So even us, we are now talking over a bunch of sockets. That is just to give that away. So it does not mean that there's a relationship necessarily between Firebase and sockets. Of course, there's a relationship between Firebase or sockets, or we wouldn't be able to even reach Firebase. We wouldn't even be able to talk today, okay? Firebase, Firestore specifically, and the observables that Firestore emits, they use sockets, okay? And they use a TPC, and they are a protocol, an application that we built on top of a TCP connection. TCP connection is that socket, that continuous connection that lives between a client and a server, or between two servers, or between two clients. It is just the way in which these observables work, the way in which you can update the database using the Firebase SDK. Eventually, it goes down to a socket, but they have built this very nice library on top, and us at Elewa and Italanta, we even built something higher on top, an application layer on top of an application layer, to make it even easier to use. That one you can find also in this open source library that we share in the presentation, ng-Solid Mono. They have some tools to help you with working with Firestore collections specifically, but we really have to document that library, by the way. That's a different discussion. But is there a relationship? Of course, because everything on the web has a relationship to sockets. HTTP is implemented using sockets. It creates a socket connection, sends data, closes the socket connection. It is just, why did we invent HTTP? It's because servers cannot handle that many sockets also at the same time, especially not in the older days. If a socket connection is open, let's say, that means on my motherboard of my PC, I need to hold one port. I need to reserve one port for one connection. Now, in the old systems, which were maybe 32-bit systems, you only had an X number of, it's a couple million, 4 million or something like that, connections that you can have at the same time. That sounds like a lot, but if you go to very large servers, it's really not. So if you have, let's say, 20 million connections coming in, and you can only hold 4 million connections at the same time, you have a problem. Sockets have evolved since then, and the socket technologies that we use these days, they can handle much more collections. Also, Firestore scales horizontally. So if my computer can no longer handle more connections, I will just put one next to it. Okay, that's the same with Cloud Functions. So HTTP was just an implementation to ease off on the server. What we see now is that now servers are becoming so many and so strong, and computer power is becoming so cheap, we can start really keeping these connections open more and more. What I'm saying is also, take it with a grain of salt is what I would say, because for example, if I talk about an EPP server or other types of servers, they will just have an SLA where you can have 10 connections at all times, and that's what you work with. Okay, that's what the rest of the connections they will reject, and then you hold a TCP connection, you maintain a TCP connection directly to them. And as I mentioned, every TCP, every UDP connection is a socket. So even us, we are talking on sockets right now. I don't know if that sort of clarifies it or makes it even more confusing.
Yeah.
It could be both.
Actually, that actually makes so much sense. Yeah. Thank you for that. Anyone else has a question? Probably ask. We have about 3 minutes. Please feel free to ask any question. If there's probably any confusion and you'd like some clarification, please just unmute yourself and ask.
Probably a lot of confusion on the last part. So also that we are open to questions. You can even reach our email. I think in the last presentation, and we'll share this presentation with Wayne to disseminate amongst all of you. We have our emails there, both that of Joy and that of me. We have our Twitter there. It's easier to reach me on email than on Twitter, I will tell you that. But if you can even reach out on LinkedIn, on messaging, we both have LinkedIn. In case of any questions, we're always open to answer. We also try to have some more topics to engage with the Angular community in the future. We are Angular fanatics ourselves. We will try to keep it a bit more, maybe with one topic instead of 5 topics like we tried now in one call. But we're very happy to share what we learn also working with all of these startups on the many different types of projects that we have, and and engage with you guys in the future if you still give us a chance after that demo.
Yeah, definitely. We're usually interested in like having people come back and like do even more sessions. So we'd be glad to have you again. Yeah, thank you very much, Gente and Joy. Thank you to everyone for joining this call. As Gente has mentioned, they will share with me all the resources that are pertinent to this session. So I'm going to also share it on the video description when I post the YouTube, when I post it on YouTube. And so you'll be able to get all the links, even their communication channels, if you want to reach them. If you want to reach out to them, either LinkedIn or Twitter, they'll provide you with all the communication links. But apart from that, I'd like to say a big thank you to our presenters, Gente and Joy, and also to you, the attendees who joined this call. And thank you very much. And we hope to see you next time. And yeah, no worries. We'll definitely schedule another session with Gente and Joy on probably expounding even more on the Akita state pattern. So apart from that, have an awesome evening, all of you. And thank you, Gente and Joy. Do you have any parting shot, maybe? I think you're mute.
No, I don't think I do, but I'll just say keep learning, keep growing, and be language agnostic.
I will go with what Joy said. Thanks a lot, everyone, for spending this late evening with us, and then we hope to see you in the future and engage further with the community. In case anyone has a question, please reach out. Even on other things, we have done quite a number of. If you want to talk about monorepos, cloud functions, cloud architecture, even Flutter, we are very happy to have any discussion that. To just hear what you're trying to do and then see what challenges you have and if we maybe have faced those challenges before. We always love working as a community, so looking forward to further engage. Thanks a lot for this invitation, and see you next time.
Thank you. Bye, guys.
Thank you, Wayne. Thank you, Joy.
Thank you, Juma.
Thank you, bye.